When thinking about the accuracy in the lab, the accuracy describes how close the measured value is to the true or accepted value. It's also a description of the validity of the measurement. The best way to determine this, the accuracy of your measurements, is to use a confidence interval. This is a statistical test that will tell you if the true value belongs in the data set that you've collected or not. So if we think about taking a lot of measurements and creating a distribution that is only broadened by our random error associated with our measurements, we can define the confidence interval as a window of values that are bounded by the lower limit and the upper limit of that window. We can then compare the true value or the accepted value to that window. And if the true value falls outside that window, then we would say with some confidence that that true value is not a part of the measurements that you have taken. So your true value is significantly different than what you measured in lab. Likewise, if that true value falls within that window, then you could say with some confidence that the true value is a part of the measurement distribution that you've collected, and therefore they are statistically significantly the same. In order to calculate this window, we need to calculate two numbers, the lower limit and the upper limit. So the confidence interval is defined by the lower limit, which is the average value minus some amount, and the upper limit, which is the average value plus some amount. This extra amount depends on the standard deviation of the measurements that you've taken and the number of measurements that you've taken. N is the number of measurements that you've taken, and T is from a table, the student's T table. So over here we see the student's T table, and to determine what T is for your data set, you need to choose a level of probability or a level of confidence. We will typically be using the 95% confident level. And then you also need to choose a degrees of freedom to coordinate on this table to pick the value, the most appropriate value. The degrees of freedom is the number of measurements that you've collected minus 1. So if you've taken 3 measurements, then your degrees of freedom would be 2, and at 95% confidence, you would then select 4.30 as the t value in this equation. You'll also notice that the n, or the number of measurements, is in the denominator here for this extra piece. So as you increase the number of measurements, even if the standard deviation or the breadth of that distribution of measurements doesn't change, you will decrease the actual window, the value of those window, upper limit and lower limit, and it will become harder to prove that a point is within that confidence interval or not.